Welcome to the CBA's Good Science Resource. As a part of our mission, we strive to collect and share important information and create safe consumer products. This is the continuation of our PFAS Educational Series. CBA Managing Director Fran Groesbeck and President of the FEC Tobias Gerfin continue discussion around this complex issue by illustrating two groups of PFAS.
So there is a lot of different levels of products that have these polymers connected, and they're not all treated the same.
First, we have to put them into two categories or two groups. One group is the fluorochemicals. These are carbon chains, rather short, maybe 6 carbons or 8 carbons. And then we have the fluoropolymers, where the chain is a lot longer, up to 1,000 or even more. The properties, as Fran described, are completely different. One of them is water soluble, which is the shorter ones, which is the fluorochemicals, and the fluoropolymers, not water soluble. They have so many distinct properties, and a lot of the applications are the fluoropolymers. There you can really go throughout our society, whether you look at cars, phones, whatever, you will find fluoropolymers on that. Some people would be shocked to see how it is, but when they hear and see the properties and the benefits, they really start to understand how beneficial the PFAS and within the PFAS group, the fluoropolymers really are.
And what Tobias just touched on, the water soluble versus non-water soluble, is actually one of the biggest keys in the impact of PFAS in the different groups. Because if it's water soluble, what that means is it'll dissolve in water. It will it'll mix in water. If it's in the ground, it would find water and it will go into it. If it's non-water soluble, it can't mix with water. It will pass right through a body of water unchanged, which also indicates if it was ever ingested, it would pass through unchanged. So the concern are the water soluble ones, I apologize. And then that distinction is very key. And fluoropolymers, as Tobias said, are not water soluble. And the reason that this whole PFAS issue gets confused is because you need we have needed the water soluble ones to get the non-water soluble ones to mix into things. So if you need to introduce a fluoropolymer into a water coating or a liquid coating, you need, I'm going to use a fancy word here, you need a fluoropolymer dispersion. And think about those two words. All it means is it's an aid to get that fluoropolymer to disperse in the liquid. Well, the fluoropolymer dispersion is a fluorochemical. And that's where the real concern came in. And that's why there were other changes made previously in like 2012. And so this distinction, this is just one of the steps in understanding PFAS. And what we're talking about today are only the known steps. There's a few more that are to come. As people like the EPA and ECHA have discovered, as the further you get into it, there's even more distinctions and steps to separate. But this is a key one, the non-water soluble and water soluble.
This is a complex issue. And I'm going to go into the difference between non-polymeric and polymeric PFAS. Did you just go over that?
This is a great starting point for PFAS because polymeric PFAS or fluoropolymers have these long chains, as Tobias mentioned, hundreds. PTFA, I think, has 1,000. Non-polymeric or fluorochemicals have shorter chains, and that's a big distinction. Tobias, do you want to touch on those two distinctions between the long and short chains?
Well, the key element is the longer it gets, the more difficult it is to take it apart. And very often the shorter ones, or let's put it this way, how reactive a substance is depends on the end. So what is really at the end of the chain? And if you have a very short chain, the ends are highly relevant. While if you have a very long chain, like a PTFE, which has more than 1,000 carbons in one chain, the ends are not relevant anymore because the chain dominates the properties. While going to a chain of 6 carbon of course, the properties of the very last molecules are by far more important. Thereby, they get water soluble. Thereby, they can have other properties. Thereby, they can even react in the human body. That is where the problem is with the fluorochemicals, where we have to be very careful, and we have to make sure that they're not getting out to the environment. While with the fluoropolymers, there is no major risk because there's no reaction, and thereby they will stay there, and there's no negative impact. They are non-toxic, and this is very important. So the people getting in touch with the fluoropolymers are in no danger.
So you just touched on the shorter chain. There's a great example some listeners or viewers may know, which is PFAA. That was a PFAS that started back in the early 2010s, and many people may know about that. You'll see it on packaging. It'll say made without PFAA. This was one of those shorter chains that dissolved in water. So as an industry, while we were asked to eliminate it by 2015, most of the industry did it right away. And I think it was within a year of the request, when this was identified, it was eliminated. And this just touches on an important thing, is that when you have these, look at this single step we've just looked at, the shorter chains versus longer chains, the strength of the bond. What we're asking here is that people open their minds to the science of this topic, and that there's so much to learn. And I think this is just such a great example of just the tip of the iceberg of learning about this topic. And that's why we're here. So if people have questions also, we hope that they engage us. We want those knowledge seekers.
So the water soluble, the shorter chains are the ones that we're trying to avoid?
Trying to understand and get a better understanding of them, because some of them have very unique and beneficial properties. So the biggest thing we don't want to do, which we've done in the past, is panic and react and rush and replace it with something that in 10, 15 years, we're going to go, shouldn't have done that. And we've done that in our history. There's many examples. Styrofoam is one of them. So we don't want to move towards that, but there are some. So again, in these groupings, Tobias touched on it before, there's like 3 different properties that you look at, and then there's grades within that. So we're trying to understand all these different chemicals. These on that side, they're inert. The fluoropolymers, which are the good guys, they're inert and they're excellent thermal insulators, and they show a huge friction resistance. But you do need some of the non-water soluble ones to help get those into production. So we're trying to understand. There's also some on the water soluble side that by themselves provide very significant benefit and protection and safety to some industries and people. There's some in the health industry, there's some in different service industries. Without them, people would go unprotected and unsafe, and we need to make sure we find the right solution before we just ban those.
If I can jump in, it's also about the complete life cycle of a product. So you have the production, and there it is the responsibility of the chemical industry and whomever then produces the product to make sure that nothing gets out to the environment that shouldn't, especially not the short chain or the fluorochemicals. While then you have the use phase, and there it's important that the consumer is protected. Let's take as an example, when you do something that goes into the human body in medicine, of course you don't want any toxic substance to get out of that product. That's the responsibility during the use phase. And then after use, you have the end of life. And in these 3 phases, we have to make sure all together to understand what is happening, and then to make sure that nothing is getting out to the environment. In the first phase, in the production, the chemical industry is used to difficult and dangerous substances. In many production steps, they know how to handle them. Sometimes they did it in the past, not to the level they should. We all agree on that. But it is something, a responsibility that they have to take care of. And the same is true for the fluorochemicals. And we know from Europe, we know from the US, that the big chemical industry is now on the way ready to make progress. And they want to make sure that nothing is getting out to the environment. We know that during use phase, the risk for the consumer is very limited in most applications because these are fluoropolymers, as Fran pointed out, inert, non-toxic. And then at the end of life, we have to make sure that we have good recycling procedures.
Thanks for watching. For more resources about the cookware and bakeware industry and membership information, visit our website at cookwareandbakeware.org.